Hi, good morning everyone. I would like to thank you all for giving me chance to explain about the static hashing and its applications in different ways, so let's just start the video.
Static hashing maps keys to fixed locations in a table for fast retrieval. It uses a hash function to convert a key into an address within a fixed size hash table. The size of the hash table and the hash function remains constant, regardless of the number of keys. The hash table is a fixed size table where keys are stored in entries called buckets, which may hold multiple keys based on collision handling. A hash function maps a key to an index in the hash table, ensuring a good distribution of keys. Methods include division, multiplication, and mid-square. Static hashing handles collisions through methods like open addressing, chaining, double hashing, and rehashing. Keys are input values for the hash function, while data represents associated information stored in the table. Lookup operations use the hash function for data retrieval, typically ensuring O1 complexity for minimal collisions. The load factor influences performance, calculated as up equals n where n is keys and m is table size. A high load factor can lead to frequent collisions.
The size of the hash table is fixed and determined in advance. It doesn't change during operations but may need manual resizing when full. A hash function generates an index for each key. Common methods include modulo, mid-square, or division. For example, if h(k) equals k mod m, key k equals 10 maps to index 10 mod m. Collisions occur when two keys map to the same index. Static hashing uses specific techniques like open addressing, chaining, and double hashing. Data retrieval is efficient because the hash function provides direct index access in constant time O1, assuming few collisions.
In static hashing, a collision occurs when two or more keys hash to the same index in the hash table. Collisions are inevitable due to the fixed size of the table. To manage collisions, various techniques are employed: open addressing and separate chaining. Open addressing stores keys directly in the table. If a collision occurs, a new index is sought using a probing method. Linear probing involves incrementing the index until an empty slot is found. Hash function, HAK plus I mod m. In quadratic probing, you probe at increasing quadratic distances. Hash, H of ki mod m. Double hashing uses a second hash function for probing. Hash HAKIK mod m. Separate chaining allows buckets to hold a data structure to store multiple keys that hash to the same index, typically a linked list. This method simplifies insertion and deletion and allows unlimited keys. However, it requires extra memory and performance may degrade with long chains. Rehashing is an option if collisions become excessive, involving creating a larger table and a new hash function. Rehashing reduces collisions, but is an expensive operation and isn't often used in strictly static hashing.
Fast data access for a well-distributed hash function. Simple to implement and suitable for relatively small datasets with known size. Inefficiency arises if the hash table becomes too full, leading to more collisions. Not suitable for dynamic environments where data size varies significantly because resizing the hash table is expensive. Static hashing is widely used in computer science and database systems due to its simplicity and efficiency for certain applications. One database indexing, used in static database systems where the size of the dataset is fixed or changes infrequently. 2 compiler design, used for symbol table management to store and retrieve information about variables and functions during compilation. 3 caching, provides quick data retrieval in caching systems where keys represent items stored in the cache. 4 static dictionaries, used to implement static dictionaries where a set of key value pairs remains constant once created. 5 network routers. Hashing is employed in static routing tables to map destination addresses to specific routes. 6 cryptography, often employed for constructing hash tables for cryptographic algorithms. 7 file systems, used in file systems to maintain directory structures or inode maps for file retrieval. 8 embedded systems, suitable for static configurations in resource-constrained environments.